Assalamu alaikum. MashaAllah, I see only 7 students. Okay, anyway, we will continue, inshallah, with a new subject. Today we will speak about enumeration, type definition, and structure. Okay, enumeration, or shortly we name it Enum, or we will use in C the keyword Enum. It's like this. We have in C or in any programming language some data type already defined in the programming language, like int, integer for integer, like real, like character. This already defined data type in the program. Sometimes it's not enough. We need to build our own data type. To build our own data type, we use keyword enum. Enum, it's a user-defined data type. Actually, it's used to assign names for integral constant. This means when you have a specific constant and you want to give name for them, you can use enum to give the names for this integers constant to make it much easy to read and maintain. For example, okay, we have some groups of data that have constant values, like weekdays. We have Saturday, Sunday, Monday. Okay, I want the user or the program just use this specific 7 days for the weekdays. But if you define, for example, the weekdays using string, then here the user can use any name, not the specific name that you want. Here you have to use enum to force the program or the user to have a specific constant for this type of or this group of data that have specific values. Like also when you speak about gender, we have male and female. Like when you speak about months of the year, we have January, February, March, April, and extra. So what's the syntax of defining enum? We use the keyword enum, then we give this name. This name of enum considered the new data type name. Like we have integer, character. When you define your enum, now you can have any variable from this type, from your enum type. Later we will see by examples what I mean. Then we use keyword enum, we give name for our enum, and we give the constant name, constant 1, constant 2, and blah, like Saturday, Sunday, Monday, for example. Okay. We said that we give for the enum names for the constant. But we know that constant have name and values. Actually, the values here integer. You can give the values for each constant, like when you said constant 1 equal 2, for example, or 0 or 1. It's depend on you. If you did not give the values like this, it will be given from the compiler sequentially starting from 0, like array. So the compiler will give values for constant 1, 0, for constant 2, 1, for constant 3, 2, and so on. So we usually, or we can use enum to create our own data type. For example, C do not have Boolean data type. Boolean to have two choices, 0 or 1, false or true, something like this. Okay. You cannot define Boolean X, for example, to have only 0 or 1. But you can check any value if it's true or false. But you cannot define variable X from the type Boolean and then X will have only 0 or 1, false or true. So to create our a new Boolean data type, to have 0 for false and 1 for true, we can use enum. Here, the example. To define enum, we use keyword enum. Okay, just a moment. Okay, we use enum keyword, then we give the name for our new data type, or for enum we give here Boolean. Then we give the constant name. I name the constant here F and T. You can name it false and true. You can name anything. And I give F 0 and I give T the value 1. Now you can define variable from this Boolean, or let us name it object from this Boolean. So here, every time you want to define a variable from this enum, you have to use the keyword enum and the name of the enum. So this two, enum and the name, to define variables. We define two variables here, bool1 and bool2. Now bool1 and bool2 can take only two values. We can use the names or the constant name F or T to assign values, or we can use the equivalent integer value, which is 0 or 1. So here I assigned for Boolean 1 the value F. It's equivalent to said Boolean 1 equals 0. It's same if you said equal 0 or if you said equal F, because the constant give you also the value or the integral value. So now I'm checking Boolean 1. Is it false? Is it F? Yes. And you see here, I use the name of the constant without any quotation, okay? Because it's constant name here. So yes, then Boolean 1 is false. There is no week 8 PDF. Actually, week 8 have the same PDF with week 7. Same PDF, week 7 for week 8 and for week 7. Okay. Now here, Boolean 2, I give value 1. 1 means T, because T equal 1 here. So if we check if Boolean 2 equal F, it's not correct, it's equal T, then this will be printed. Boolean 2 is true. Of course, I can check if it's equal T. Is it equal T? Yes, because when I assign one, this similar like assigning T, assigning the constant name or the constant value. So here we defined our new variable Boolean, or our new data type Boolean, and we can define variable from this data type. Every time you have to use the enum keyword to define the variable and then the name of the enum. Okay, so this example also. So we use the enum keyword to declare for the declaration, then the enum variable or enum name, then we give the constant values or the constant name. If we did not assign value, the values will taken as 0, 1, 2, and so on. Okay, what about make instant or instantation, or make variables or object from this enum? We have to use the name of the enum with the keyword enum. Then we can define any object or any variable from this enum. We can also assign values or compare or anything like this. Here we assigning Wednesday. Wednesday it's 0, 1, 2, it's 3. So it's like we have in the memory variable day and it's have value 3. Okay, here example also for main colors, red, blue, and yellow. Then we are defining a variable. So we use the keyword enum, we use the name of the enum, and we give name for this object or variable. So we can name it X, Y, Z, anything to define another variable from enum main color we can use like this. Same enum main color X, for example. Then now X could have any value from here, red, blue, or yellow. So I can give this red, this X value red, for example. Or even I can give X value 1. What this mean if I give X value 1? Now, X, is it red or blue or yellow? No. After give X value 1, it's not red. The index inside enum, if you did not give the index, if you did not clearly said that red equal 1 or equal 2, then it's a start like array. It's starting from 0. So red actually equals 0, 1, or blue equal 1, and yellow equal 2. So now when I give X the value 1, this means it's blue, because we start the index from 0. So we can now, if we have here, for example, pixel as object or variable from this enum, it could take any value, red or blue or yellow, or could take any integral value, 0, 1, or 2. 0 means red, 1 means blue, 2 means yellow. So we give here pixel blue. We can check using if statement if pixel equal red or equal blue, or else it's equal yellow. It's equal blue, so this will be the output. Okay. Here, another example. As we see here, we did not assign value, then man will take value 1, Tuesday, 0, sorry, Monday, Tuesday, 1, here, 2, 3, 4, 5, and 6. But we know that we usually use 1 for the first day, 2, because it's 7 days. So it's better to assign 1 directly here. We will see this example. So we have enum week, this is the data type, and we have object or variable day. We assign for the day Wednesday, which is 2. Now, when we print day, we printing Wednesday or the value. Actually, when we print the value or the variable from enum, we are printing the equivalent index or value. So it's integer. We use here %d, because the value that will be printed here, it's integer. So the output will be 2, which is the value for Wednesday. not Wednesday itself. If you want to print Wednesday itself, you have to print it as string like this. Print if and like any statement, Wednesday, not the variable itself. So maybe you can check here if a statement, if we have Wednesday, then print Wednesday. If you want to print the name itself, but if you use the variable like this, it will print the integral value or the integer value that equivalent to the constant name. Okay, here, same idea, but the different here. You see, we said that the values here actually it's constant, and each constant have integral value. So we can use it with for loop, we can use it for anything that we can use the integer. So when we said we have for loop, I starting from j, it's similar like you said I equal January, it's 0 index here. It's equivalent here. It's I equal 0. This means we're starting from I0. And when we said I less than or equal December, this 0, 1, 2 until 11, it's equivalent that I less than or equal 11 actually. So this for loop starting from 0 until 11, and we printing the I, it's integer, so it will print from 0, 1, 2 until 11. So when we use the names of the constants, it's actually like we are using the values inside each constant or equivalent to each constant. Okay, now we will speak about initialization. Give initial value for variables or for a constant name inside the Enum. Okay, we can assign any value. If you did not assign value, I said it will start from 0. If you assign value, it will take the now working not 0, working equal 1. Now you can give same value. We will speak about some facts about initialization. We can give two enum names or two enum constant like here, filled and freeze, the same value. We give it 0 and 0. Now if you printing like this, printing working, failed, freeze, this will print working equal 1, so it will print 1, 0, 0. So here the output will be integer for each constant name from this enum. Okay, so I can give same value, same integral value for 2 or more constant in this enum or in any enum. Okay, let's say see another fact. If we do not explicitly assign values to enum names, it will take values starting from 0, and every one will be +1 from the previous. So starting from 0, 1, 2, blah, blah. This we already know. Fact 3, we can assign values to some name in any order. So I can give for any constant. When I said for some names, this means constant from the enum. I can give any values in any order. It's not necessary to be ordered. Okay. So I can give Sunday equal 2, Tuesday equal 5, Thursday equal 10. Even I can give Sunday equal, for example, not 1, equal 12. It's not necessary to be less than the next one. Okay. So I can give or assign any values for the constants inside the enum in any order. What about the remain constant? You look, Monday we did not give any value. Wednesday we did not give value. Friday, Saturday, actually it will take the previous value plus 1. So all unassigned constant or name get value like previous name plus 1. So when we want, when compiler want to give value for Monday, it will look to Sunday. It's equal 1 plus 1, so it will take value 2. Wednesday, it will look to Tuesday. It's equal 5. 5 plus 1, so it's equal 6. Friday, it will look to Thursday. It's 10 plus 1, so it's equal 11. Saturday will be Friday plus 1, so it's equal 12. Now, if we printing Sunday, Monday, Tuesday until Saturday, we know that Sunday it's 1 because we give the value. Monday it's 2. It's from the compiler. It's taken from Sunday plus 1. Thursday, Tuesday, it's 5 because we already assigned 5 for it. And Wednesday, it will take 6 because it's Tuesday plus 1. Thursday it's 10 because we give it 10. Friday it's 11 because it's Thursday plus 1. And Saturday it's 12 because it's Friday plus 1. So we can give values in any order, but any constant inside this enum that do not have value, it will be previous one or the one before it plus 1. Okay. Also, the values assigned in to enum names must be integer, as we said. It's not character or a string. Fact number 5, all enum names or constants must be unique. So you cannot, of course, in their scope. If the scope like this outside the main function and any functions is mean global, So you cannot have any name repeated here. Each name inside the enum should be unique. But if you have, for example, function 1 and have declaration for its own enum, and function 2 and have declaration for its own enum, here you can have same name. You can have inside this enum, for example, value x, and inside this enum same value x. Why? Because this enum scope will be inside the function only. But if it's a global, it's a scope all the program, the whole program. You cannot give same name for another enum. So same constant name. So if you look instead, we have working and failed. For result, we have failed and passed. So it's error here because failed repeated here, not unique name. So when you try to compile this one, you will get compiler error because failed has previous declaration. He speak about failed here in the result. It have a previous declaration inside the state. Okay. Another example for Enum. Here in this example, I want to mention two things. Here we give value starting from 1. This means we're starting 1, 2, 3, 4. Okay. Another thing, if you look to examples here, for example, here we define enum day, then we define variable from this enum day, we define variable or object D in two separated lines. Here in this example, if you look to D, we defined it directly after the enum. So actually it's similar. Here we defining variable D. Okay, so we can also define many variables here. So if we have enum day X, Y, Z, the names, I don't want to write the whole names. Or let me name them by characters only. Okay, if we have enum days, Saturday or Sunday, Tuesday, Wednesday, Thursday, and Friday, Saturday. Okay, now we can define variable D1, comma D2, comma D3, comma D4. Okay, then you have the semicolon. So now we have variable D1, D2, D3, D4 from the type enum day at the same line like this. So later I can use D and give any value from inside the enum like Thursday here or Friday or any value. Okay, so I have two ways to define variables from the enum at the same directly after the enum or in separate line. But if in separate line, each time you define variable, you have to use the keyword enum plus the name of the enum. For example, here day, enum day. Okay. If enum is defined as a global or globally, actually it can be used as a return value or as a parameter for function. If it's a global, why? Because it's outside an function, so I can use it as any variable. I can use it as a return value. This means, like example here, find the state, it's a function from type enum state. Here enum state, it's our enum. So because this function from the type enum state, it will return like when you define function from type integer function. What's the value that will return from it? Any integer value. Could be any variable x, y from type integer, or even value directly like this. It's same. Here, the type of this function, it's from enum state. So it should return value from enum state. So, or variable. So we defined here variable current state and give initial value 2. So we can return current state because it's variable from enum state type. So this function will return 2 as a value from this current state. If I used it here, I give this many times. It's actually same like if statement, if else statement. We have condition, and if this condition is true, this will happen after the question mark, after the 2 dots, if the condition false. So it's like if else. It's similar. Okay, find the state. Find the state. This means when I call this function, I will get value 2, the return value. So it's 2. Is it equal to working? Working equals 0. So it's like I ask if 2 equals 0. Of course, it's false. So it will print not working. Okay, then I use enum when I want our variable to have a specific set of values. I want to force the user to have only specific set of values. Like when we speak about gender, we have male and female. When we speak about education, we have primary school, secondary, high school, graduate, master, PhD, and so on. When we speak about direction, we have north, south. So when you have a specific set of values and you want to force the user to use only this specific set of values, then you will use enum. And if you want to give values a constant names. Also for weekdays, for months of the year. If you have, for example, a game, like when we gives a game for the homework. I forget the name of the game. Okay, you have win, or you have lose, or you have checkpoint, or collect point, like this. Then you can use Enum. So the issue here, I have to use Enum keyword every time I want to define a variable or object from this Enum. But there's a solution for this, to stop using Enum keyword every time. I can use something we called it type definition, to define my type of Enum and give only short name or alias name for this Enum. So actually, type definition in C is used to give any data type, not just Enum, a new name. Any data type, integer, float, and any data type, you can give it a new name. Okay. Also, Enum data type, I can give it a new name. Then this alias name or a new name becomes the name of the variable, and I can use it as I use the variable itself. I can use it instead of the data type, the new name, because it's equivalent to the name of the data type. So what's the syntax? I use keyword type definition, then the name of the data type. For example, Enum day. The new name or the alias name that I can use it instead of Enum day, for example, days. Now I can use days like this to define any variable directly. Days, day 1, day 2. Okay. Also, I can define days D3, for example. So this, instead of writing Enum day every time. Here example, I can use for any data type. Type definition, unsigned integer. This is the existing name, the new name, unit. So now I can use unit instead of unsigned integer. In this line, I use unit A and B. This means A, it's unsigned integer, B, it's unsigned integer. So this example, we define our, this one we already created in Boolean before, in example before that. Now we can define data type. Okay, to change the name in Boolean, or not to change, to give equivalent name or alias name, bool. Now bool is the Enum Boolean. I can define Enum Boolean data type. I can define now any variable, like here. From bool, I defined is it true. I can use bool define x. This means x, it's Enum Boolean. So now I can give x value, for example, false. I can define another time, bool y. So instead of every time Enum Boolean x, Enum Boolean y, Enum Boolean z, Now I use the alias name only, like nickname, yes. Here, in this example, instead of write like this in 2 lines, type definition and defining the enum here, then defining the type here, I can use directly type definition, then enum days, then day. Now day, this is the alias name for enum days, not variable. It's different than this example. In this example, it's variable or object. Actually, the correct name object. Okay, but here it's alias name or nickname for this enum days. So you can use it to define variables. Day, now it's equivalent to enum days. Okay, so it's day, this means enum days, day 1, day 2. So day 1, it's from type now enum day. Day 2, it's from the type enum days. So it can take any value from these values. Okay, so I can say day 1 equal Thursday, Tuesday, Wednesday, anything. I can use day 2 equal Friday, Saturday, anything also. When I print day 1 or day 2, it will be printed as integer value. So day 1 equal Thursday or Tuesday, sorry, Thursday. Okay, so we're starting from 1, as we can see here. So this is 2, 3, 4. So it's this will print 4, and this will print the day 2 number is Friday, which is 5. Okay, we will take 10 minutes break. We will return 1:45. 10 minutes break, or break 10 minutes. Okay, see you after 10 minutes. Okay, assalamu alaikum again. How many students around? Raise your hand, please. Muhammad Khalid, me and you only. Okay, I will wait for another 1 minute, then and Maha. Okay, and I will continue, inshallah. Do you have exam today or tomorrow? I wonder where's the students. Oh, that's why most students not around. Okay, let's continue. Hopefully we will finish early for you to prepare yourself more. Struct or structure. Okay, if we have a single value in C, we will use the normal or traditional data type or the fundamental data type like integer, float for this value. For example, if we have integer 5, 10, okay, any integer, we will define from type integer x, for example, or float x, or double x, or even character, or okay. What about if you have more than character, like in string? You will use array. So if you have values from the same data type, you will use array. If you have single value from any fundamental data type like integer, float, you will use this data type: integer, float, real, character. What about if I have different data type values that logically related? I cannot use here the fundamental data type like integer, float, or I cannot even use array to store these different values but related at the same time. Like, for example, if we have for students, we have name of the student. It's from, it could be string. If we have the student number, it's integer, could be. If we have birth date, actually it's number for the day, number for the month, and number of the year. Yes. So we cannot put this different type of value in array or in a single or fundamental data type. That's why in C there is something called struct. Struct, it's like when you said the file of something, okay? It's not actual file, it's defining different data type in one block. So struct used to group different data type of variables in one structure or one block. It's actually important if you want to use for data like this, like the database, or like data related to each other to gather it in one block. Also, it's important in object-oriented. Even in object-oriented, there's something called a class. It's like struct, and it could have many struct. Okay, it's not our job now. We will focus in the struct. So struct to group different type of variables in one structure or in one block. Okay, here example, we have struct keyword and we have label here. Label or name of this struct, we name it student. Then we have the group of variables inside this struct. For example, first name, it's array from 64 character. Last name also array. ID array if it's have some special character, okay? And the score from type integer. So I can have any regular type here inside the struct. Just grouping this variable in one block or one struct. Okay. Now I can use struct with the label like enum to define object or variable. It's better to name it object from this struct. So we have std1, its object or instance from this struct. Same thing, we can use struct student. We have to use this struct and the label name every time we define object from it. Also, we can use same. We can use type definition here. Type definition and give alias name here. Same like Enum. Okay, now I can read the values using this. To use the variable inside the struct, you have to use the object. For example, here I std1, then dot the variable name. Here first name, then first name. So I will not use first name directly. First name after the object name, and they have dot in the middle. I can now read or even print the values. Of course, because this string in the scanf we use only the name, but if it's integer or a numerical value, we have to use at here, like any integer. Actually, it's integer, okay, but we mentioned that it's following this object. Okay, so labeling actually important, but you can use without label. If you did not label here, then you have to define the objects here. If you did not have label like this, then you cannot use definition in separate line like this. So you have to define the object here as std1. That's why labeling important. You can ignore label, but label important. Why? Because labeling allow you to define as many objects as you can anywhere inside your code. But if you did not have label, you have to define all your objects here directly after the struct. So if you do not have label, you have to define all the variables or the object with the struct directly. If you use label, you can define at any point in your program the object, like here. Okay. Here, another example. We define a struct without label. So we have to define the object directly after the struct, as here. You can see we have object from this struct, you, your sister, your brother. So now I can use this variable through the object name, u.month, u.year, u.day, u.year, or your sister.month. Okay, now there's many advantage for using struct. First advance, collecting related variables in one structure, in one block. So it's more readable, more understandable. Like here, I understand that this information about students. But if I define without a struct, it's become difficult to understand or read what do you mean, especially inside the code here. Okay, another issue, the number of defined variable. Here I defined only 3 variables, but if I did not use a struct and I want to give your year, month, day, and your sister year, month, day, and your brother year, month, day, so I need variable for 3 variables for you, 3 variables for your sisters, 3 variables for your brother. So I need 9 variables, but here I defined only 3 variables. Imagine if we want to take information about 20 persons, or 20 information for each person. So if I have 3 persons and 20 variable for each person, if I did not use a struct, this means I need 60 variable. So it's using structs much readable and you define less variables, so it will be more efficient. Also, another advantage that you can copy the whole struct easily in one sentence. If you give, for example, the object, your sister, give it information, you can easily copy this information to another object, for example, you, by only assign. This assignment mean copy all the data for all variable from this object to this object. But if you don't have struct, this mean your months equal your sister months, your day equal your sister day, your year equal. What about if I have 7 or 8? Then 7 or 8 lines. But using struct, it's only one line to copy the data from one to another structure. Even I can have nested structure, like if I want information about person or about a student, and it's contain the birth of date. Birth of date have 3 variables, and the person information have another variables. So I can put structure like this inside another structure. This means I could have parent structure and child structure. I can define any structure inside another structure. But here you have to focus. When you define like this, the parent, the child structure should have object definition inside the parent structure. Why? Because when you want to use data from child, you will use the object name of the child dot object name of parent dot object name of the child. Now you can reach the variable here. So to use months, you will use the object of the parent structure which is person dot the object of the child, which is born information dot the variable name. So I can read or print like this. This is about the nested structure. Of course, you can use like this. You can use here structure and give a label person. Then you have to define in another sentence here the object structure or struct person B1, for example. Now you can use B1 here to read born information, month, year, blah. Also, you will use B1 or person dot name and blah. Okay, what about give initial values for the structure? You have 2 ways. If you have label, you can use initialization in separate line like this. We have label, then we can define object, and in anywhere I can give initial value. To give initial value, you will use this zigzag practice, yes, or then it's depend on data type. Name, it's from type string, so it's between double quotation. Length, it's from integer, so it take integer value. Between each value you have comma. Or you can give the initial value directly here at the same line with the struct definition. Of course, here you can, instead of give the initial value here, you can give in separate line also, but because we don't have here label, So we have to define the object here, but initial value could be in separate line. But here, because we have the labels, so we can give the object in separate line. So now we can set person equal Ali and any integer, for example 157, anything. Okay, this about initial value. Okay, now we can use array with structure. What about if I have file for more than one person? What about if I have information about more than one student, about more than one person, about more than one employee? So now we have a different value from one struct. In this way, we can have array of struct, array of structure. Here in this example, we have a structure birth date. Here another way to have parent and child structure, or to have nested structure. We can define the child structure outside like this. Then I can have object from it inside the parent. This means this parent structure and this child structure. I define the child structure outside. Then inside it, I define the object here. This is the structure name, structure birth date, and define object date. Now date as object, it's part from person data structure. Okay, now I can define array from this person data structure. So to define array of integer, you define like this, integer x, and give number of element, for example 50. Same thing, instead of integer, we use struct person data as a data type. Then we define person and we give number of element 3. To give initial value for array like this, you have the elements for the first line, comma, elements for the second line, comma, elements for the third line. Okay, now we said person, it's from structure type, so it will started with this practice and end with this practice. And inside person data, we have here also its structure from the type date. That's why we use for it also this practice. Now, like any array, I can use for loop to the number of elements. It's 3 elements starting from 0. Like any array, index is starting from 0, 1 until 2. So from 0 until 2, this means before reaching 3, less than 3. This not related to the structure, it's only print the index. Now to print first element from the first line of the array, we use like this, person and the index dot name. First name index 0. This means person 0 dot name. Person 0 dot name Ali. Person 0 dot length, it's 17 point. Then now person 0 dot date, which is object or another structure, dot day 17, dot day dot month 2, dot year 1976. So 17 to 1. This one we printed here, as you can see. Okay, next loop, I become 2, so I become 1. So we speak about person index in 1. The index is starting 0, 1, 2. So we speak about Ahmad now. So Ahmad information. Next loop, I become 2. So we speak about Omar information. And so on. So we can use array of structure. Even we can use pointer for the structure. We can have pointer for single structure, or we can have pointer for array of structure. Only one different. I will speak about the different. Let me define here structure person data and another pointer ptr2. Okay, and I will define structure person data person 2. Okay. Now look here, it's same like before. And here we have array of structure. The only addition here, we have pointer, and we make this pointer pointed to person array, pointed to this structure array. Actually, if you remember when we talked about array and pointer, it's same idea. When we speak about array like this, doesn't matter, inside here may be structure for every element here. It's from type structure and have variable. Okay, but the array itself name, it's actually a pointer for the first element. So to make pointer, BTR point to this array, this person as array of structure, it has the address of the first element. So BTR now pointed to the first element. So we give the address of this array to BTR. This is the output. This is what happened like this. Okay. What about if the structure only single structure like person2? It's like any variable x, y, z. You have only variable from type structure person2, and you have address in the memory. Actually, person2 now, it's not equivalent to the address, it's name of this variable from type structure. So to make BTR pointed here, you need the address. So if I want BTR to point here, I have to give address of person2. So BTR2 equal address sign, address of person2. Why here we use address and here we did not use address? Because the array here, it's array of person, the array itself has the address of the first element. But here we speak about single structure, like any single variable. It have name and address. To get the address, you have to use address sign here. Okay, how we use, now we return to our idea. Here we have pointer pointed to the array of persons. This person1, person2, and person3. And we have now pointer BTR pointed to it. Okay, now we can use for loop to move the pointer. And how to get value using pointer? We use this way. Pointer name BTR, then we use this arrow. It's not actually arrow, it's minus and this arrow head. Okay, and then we can use the names of variable inside this structure. So to print the name or to read the name, we use BTR, this arrow, and name. BTR, arrow, and links. BTR, arrow, and we have here date, then dot day, because date itself object from this structure. So it's same, instead of use the name of the array with the index, we use BTR with this arrow. First time BTR just pointed to the first structure. If we use BTR plus plus, this means move BTR to the next structure. So the next person. So first time I print first person, which is Ali information. Second time Ahmed information. Okay. Third for loop will be third person, which is Omar information, and so on. This last example, it's similar like the example of Enum. It's about passing structure to the function. Of course, we need to create the structure as global, like this. Then we can use this structure as a definition for the function or declaration of the function, like the enum, like any variable, like integer, like this means this function get detail will return structure or object for this structure. Like if you have integer, it will return integer value. This object has the value of the structure. Okay, because we defined it like this here. Inside the function, we have the structure student and we have object. Then after that, we can read the information of the structure and then return the data from this object. So it's return all the readed information in, that inside this object. Another thing, we can also use the structure object here as a passing parameter or passing variable for the function. This function, let trace here, we have the main structure student array of structure of 3 elements. Now inside using for loop, we are reading using get detail function, this one. We are reading and put inside the array. We are reading first object and put it in first element of the array. Second time in the second, and so on until 3 times. So we are reading 3 information about student and we put it inside the array. Now another for loop to make the output, and we are calling this function display and pass the array elements, not the whole array, only the elements, which is object from the structure. It's different than passing std array. Like this, you are passing the whole array. Like this, you are passing only element by element, which it's similar like if you pass only one object. That's why in display we define only object as an argument for this function, not array. Why? Because we are not passing the array, we passing only elements. And now we are only printing std first name, last name, and so on. Okay, let's run the code and then we finish. Okay, this is the code. We're defining the structure. This for declaration only, and we are reading first 3 structure, put them in the array. We printing using display detail one by one, object by object. So we defining here only object from this structure. Take first object and print. Then array will moving here. If you passing the array, then the first statement will be here. But we are passing elements here. Okay, run. Now it will ask you for the first student information For example, Ali and last name Omar, ID, any ID, score, and second student, third student, and so on. Then, after reading, printing the details. Okay, that's all for today. See you inshallah next week, and good luck in our exam. Hopefully you will study well for our exam inshallah. Anything before we leaving or end this meeting? Okay, seems again only me and you, Muhammad. See you inshallah next week, all of you, if anyone else around. Assalamu alaikum. Okay, see you, see you, Muhammad. Seems the others are not around. Assalamu alaikum.